So we will continue our journey with Pipage rounding, which was interrupted because of the undesirable events that happened. Example, the classroom was taken by the biology class, and yeah, so that was the main reason, but there were also some subsidiary reasons, like I got headache. Okay, either way. Okay, so the problem we were interested in is that, so the, as I told you, that this Pipage rounding is in principle very much similar to the rounding procedure of rotate, which we did for bipartite matching, where we started with a feasible solution to bipartite matching and converted into a integral solution of the same weight, right, of the same LP value. Okay, so that was the basic principle of this. And now Pipage rounding is useful for functions of something like some sort of convex kind of functions. Okay, so if you recall correctly, we said that, okay, okay, so this is the setting for Pipage rounding or Pipage rounding, whatever. Okay, so if you remember, we wanted to maximize a function f on okay, a function f on m variables over 0 1 to the power m, and with a polytope p. Okay, and what was that? Basically, we wanted to maximize this function f of x, x being in this polytope, right. So we said that this is what our objective was, right, and what I told you that, so basically what it says that, so we had two conditions P A. So what was the first condition is that if you are given me a non-integral x in P, if you are given me a non-integral x in P, then we can efficiently find a vector and two scalars, find a vector Vx in Rm and two scalars alpha x and beta x in R, in reals. Okay, and what was the property? So in R, but they are greater than 0, okay, in R, such that what was the property? What was the property? Such that if I, such that x plus Vx alpha x and x minus Vx beta x has strictly less number of non-zero, what do you call, non-integral coordinates, had strictly less number of non-integral coordinates. Is that fine? So that was our first than x. So basically what I am saying that if I give you a sum x in P, then you can efficiently give me three things: a vertex or a vector, alpha x, beta x, some numbers, such that this property holds. Is that fine? And secondly, what was that? For all x in P, what we said is that the property PV was for all x in P, okay, the function f is convex, okay, in the direction of the vector Vx, okay, of the vector Vx, and more precisely what I mean by this, more precisely the function gt of x, right, it is a function which is like, okay, which you define as f x plus t Vx, so like x is fixed, Vx is, t is something which is varying, okay, t is a variable. My bad. Okay, you are right. Okay, is a convex function, yesterday also I made this mistake, is a convex function over the variable t in R. Okay, so this is what it means. Okay, and what did I? So I said that if you have such a function, if you want to optimize a function f with this property, right, for which you have two properties, a PA property and a PB property, then what the theorem we proved? Then we proved the following theorem, right, which is very simple theorem to prove, is that if conditions PA and PB are met, okay, then given any x in the polytope, right. So given any feasible solution, right, what can I do? There exists an efficient algorithm that outputs what? X int, which is element of 0, 1 to m intersection the polytope, right, the integral coordinate in this, and what are the property? Such that f of x int is greater than equal to f of x, right. So if you give me, so this is basically the rounding procedure. What's the rounding procedure tells me? That if you give me an x in the polytope, then I will output you an integral value in the integral coordinate in the polytope, whose value is as good as it for x, right. And how did the algorithm do it? Basically we started with, so what the algorithm was? Algorithm was fairly simple. You started with x, and while number of non-zero coordinate was greater than 0, we did something, right. We basically found Vx, alpha x, beta x, and whichever the value, either fx plus Vx alpha x or fx minus beta x Vx, whatever, whichever was the maximum, I took maximum, whichever was maximum, you substituted x with that, and you kept on doing this, right. And because you know that the max of these two objects is at least as good as f of x, we were able to show that at no point the value decreases, but every time at least one coordinate is becoming integral, right. So the number of times this loop is going to run is m times, okay, and we gave this proof yesterday.
Saket,
Yes.
when we say one coordinate becomes integer, we are sort of also assuming that the no coordinate goes from integer to non-integer, like it remains, whatever has become integer should remain integer.
Look at this, no, Sushmita, that's a property, has strictly less number of,
But that does not mean that integral becomes non-integral, but more non-integral becomes integral and you make it one.
What is the statement like?
such that has strictly less number of non-integral coordinates than x.
It's not just over the numbers also, right?
How did it? Of course, imagine yourself that, think about it. I had m, I went to something which had m minus 1, next is m minus 2, I don't care, no?
Suppose some number that is also
That doesn't matter, you read this, whatever you give me, whatever I output you has strictly less number of integral coordinates,
non-integral.
non-integral coordinates.
Okay, so fine. In m steps, everything should.
Yeah, so like who changes, what changes, why should I care? All I care is my measure. My measure is number of non-integral coordinates. Every time, every step, it strictly decreases, and that's all that matters. Who changes, what changes is not important. Okay, and now if you remember how, so for our max, what is that called? We were doing max coverage, right? And for max coverage, what was the function f of x that we were trying to optimize? Do you remember? F of x was summation I in u, okay, 1 minus product, okay, 1 second, j in 1 to m, because this was S1, S2, Sm, right, sets, I is in Sj 1 minus xj. Was that correct? Because now notice this, wait, okay, when if an element is covered by some set, it means that term will become 0. So, that will contribute 1. If no set, then xj is set to 0. So, this product will turn out to be 1, and 1 minus 1 is 0. So, this precisely counts number of elements covered. If these xi's are element of 0 comma 1. Okay, this is it. What? No, it is xj. Wait, the letter. What is I? There is no variable.
Element of I is element of universe.
Yes.
Its corresponding variable was?
There was no variable for element. Okay. So, now I have to show that, and x is, of course, remember the polytope we were talking about. Our polytope was x is in 0 comma 1 m, and summation of x equal to k, right. So, this is, so I am not writing right, you can write it's k. Okay. So, now I have to show to you that it satisfies the property PA property, right. Concretely you have to so that it satisfies the PA property. So, you gave me some x, okay, you gave me some x, okay, which is an m length vector. Okay. Suppose this is a pth coordinate and suppose this is qth coordinate. Okay. Now, what you know about summation of xj is equal to k, right. If the summation of xj is equal to k, I claim there are two coordinates which is non-integral. Do you agree? If summation of xj is an integer, then I cannot have just one coordinate being non-integral. You understand? Yes or no? You look very confused. Right? If other coordinates sums to an integer and this is a non-integer, I will get a non-integral value, which implies that if x has non-integral values, then there are two. Okay?
But that is too something.
Okay. Suppose my sum is 5, okay, of xi's, okay,
Yep.
because summation of xj is equal to k, right,
Right.
and k is an integer.
Right.
So, if k minus 1 people together forms, so if k minus 1 is integer, then their sum is also an integer.
Right.
They,
Why are we saying that k minus 1s are integral?
that is why, so I am saying if x is non-integral, if summation of xj is not integral, right. So, if I am saying that if x, look at this vector x, it is a non-integral vector, meaning there are some fractional values here.
Right.
Okay, but the sum of this fractional value is equal to integer, because I have a constraint that summation of xj is equal to k, which is an integer,
Right.
right. So, if you sum some fractional numbers equal to some integer, how many and you know that you have at least one fractional number, then how many fractional numbers should you have?
All can be fractions. No?
All can be, but at least two have to be.
But at least 2 is there, no?
So at least 2, you are saying at least 2 are fractions or at least 2 are integers?
At least 2 are fraction.
Okay, sorry. Okay, yeah.
Then there are two coordinates P and Q such that xp and xq are not integral. That's all that I'm claiming. And that is xp, and this is, let's call this value xp, and this is xq. Okay. So now what do I need to give you? I need to give you Vx in Rm, and I have to give you alpha x and beta x, which is more than R. Okay. So what you know about that xp is greater than 0, xq is greater than 0, right? Now let me first tell you a vector Vx. Vx is going to be EP minus EQ. So what is EP? EP is nothing but a m length vector with pth coordinate 1 and 0 everywhere. Okay. What is my EQ? Is a 0 coordinate everywhere except at the qth coordinate it is 1. So it is Vx in EP minus EQ. Is that fine? Now alpha x is xp, beta x is xq. Now let's see if these satisfy all the three properties. You understand what I'm saying? Wait. Okay. This is not how I should say. Wait. Huh. EP is a characteristic. It's not characteristic vector, Sushmita. That's not called characteristic vector, right? What?
Is representing a vertex.
No, Sushmita, P is a coordinate.
Okay, what is EP?
EP is this vector
It has one where?
at the pth coordinate.
Okay, so it's so it's standard vector. Okay.
No, it's not characteristic
Right,
vector.
right, sorry. Yeah, it's standard vector. Okay. It's a PH coordinate.
One second,
But
guys.
just-
1 second, please, 1 second. These are I had
I was just asking that the fact that you have one in the pth position of x, that P itself represents element in the ground set.
it represents a set, Sushmita, set, like set. What is
Yeah, x's are the set.
1 second, Sushmita, let me write it down. I'll just get completely confused. I will, if it is wrong, I will fix it when I will do the computation. Okay. 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 Can I rub now? Okay, so this is, so what I do now, so I have to show what, right? I can find a scalars alpha x beta x such that this has and this had something. Am I right? Okay, so let's try to do x plus Vx plus alpha x. Okay, so what is x? So x is that. Here it is xp, here it is xq, and something. Right? Okay. Now let's look at, suppose my minimum is xp. Is it, am I doing something correctly? let's see. I don't know. We will figure it out. What happens? Okay, we'll figure out like whether this is this or that is that. Like, but something should work out. Okay. Okay. So let's do x plus vx alpha x. Right. It could be this or it could be this. Okay. So let's suppose I want to add plus xp. Right. So what am I going to add? I'm going to add xp to vx. Right. So I have to do, this is x, and what I have to do, vx plus vx into alpha x. So if I do vx into alpha x, what I'm going to get? I will get, basically I'm going to get vx plus alpha x. If I do, I'm going to get what? xp, like it is ep minus euq. So I'm going to, if I multiply ep minus euq, I'm going to get, I will get some xp here, right? If I, at least the way, if it is xp, and what will I get here? Minus xq. Is this okay? It is not what I, is that fine? So then what will happen if I do this? Huh? Why? Because it's vx plus alpha x, no? Plus. It depends, right? What I choose, right? X plus vx. This is x plus vx plus alpha x, right? I'm saying, I'm not adding it. I'm saying, what is this vx alpha x? Why?
Because minimum is xp.
Huh, so?
But that is p minus rho q.
Yeah, so one coordinate is 1, another coordinate is minus 1.
Huh, so? So this is why it's minus xq, no?
Oh, p.
P. Okay. This is not what I want. Wait, wait. Have patience. Is that fine? Let's see now. Okay. Wait, wait. Okay, now let's try. What is that? Okay, it's not that I have some. Okay, now what is vx alpha x? What is vx alpha x? Now, if suppose minimum is xp, then what is vx alpha x? xq. If it is xq, then what are you going to get here? Right? xp plus xq, you will get here xq, right? And here what will you get? Minus xq. So if I add them up, right? If I add them up, I will get the same coordinate here. Here I will get xp plus xq, but here I will get 0. Is that fine? Okay. So if my minimum is this, but suppose my minimum is 1 minus xp. If my minimum is 1 minus xp, then what will I get? I will get here, on this place, I will get, in that case, I will get 1 minus xp, right? Here also I will get xp minus 1. But when I sum them up, what will I get here? 1, and what will I get? I will get something here, I don't care. But in either way, in both coordinates, both vectors, my number of ones have decreased. Okay. Similarly, you can show here also the number of ones will decrease. If you want, I can do that, but like, okay. Okay, so let's try to do this for the other one. Okay. So what is the other one? Other one is minus vx beta x. Minus vx beta x. Okay. So what is this coordinate? Because all are 0, nothing will change except suppose it is 1 minus x cube here, right? Then what will I get? What will I get here? Yes?
So if the minimum is 1 minus xp,
Okay.
so why
Minimum is not minus xp, right?
1 minus xp.
Minimum is 1 minus xp or xq because it is the minimum of these two numbers, no?
right? So if it is xq, we have finally increased
Let's look at Pallavi. Let's look at beta x, okay, and that will also make clear your doubts. Okay, just 1 second. Okay, so now what is minus vx beta x, right? Suppose my beta x is 1 minus q, minimum is this 1 minus x q, then what will I get? What is minus vx beta x? I am going to get at the xp position, what I am going to get? Huh? xq minus 1. And what I am going to get here? Right? What will I get here? No, please. It is. All of your people is confusing me. What are you saying? It is this, right? So there is a minus there, so it will get plus, right? So it is just 1 minus x cube. Okay. Okay. Now if you sum them up, you will get 1 here, and I don't care about other places anyway. Rest are same anyway. Here something, but at least I've got 1 extra coordinates here. Okay. Now
We don't care, but I have doubt here. So what is the guarantee that it is not negative?
what do you mean by not negative?
Like when we do xp plus xq minus 1,
Okay.
suppose it becomes negative.
So
So then it is not feasible.
how can it become negative? It's a minimum quantity, no? Look at this. Look at this.
Greater than 1.
Yeah, because look at this, right? This is, you are right, but look at, this is why we are doing minimum, no? It shouldn't become negative, but perfectly fine. But look at, what will be the sum for there? This is what?
xp plus xq minus 1.
Wait, I mean, is that what it is? xp plus 1. But wait. One minus x was smaller than xp.
Yes.
That's it, right?
Right.
Okay, that's it. That is why it is the minimum here, and the other coordinate doesn't matter. Okay. Okay. Now, if it is xp here, then what will I get here? I will get here minus xp, right? And what will here? Xp. So this is, if you xp plus xq, it is 0. You don't care anyway. Is that fine, Pallavi? Right? Yeah. So this will be like xp plus xq, which you don't care, and this is 0. So either way, I am still getting a feasible solution, and this is why I did minimum. Otherwise, it will become negative or something. You understand? So I mean, this is not some like some engineering science. This is like one can do it oneself. Okay. Once I have told you what EP, I also did exactly. I just tried to set up some of these things, and it came. This is not some rocket science. Okay. Okay. Is that fine? Okay. Now we need to establish property PB, convexity. Right? We need to show convexity in terms of T. So, okay. So what we have to show? That Gx of T, what is Gx of T here? I forgot what, yeah. So what is f x plus T times Ep minus Eq is a convex function over variability. This is what I have to show. Is that fine? Right? And now notice that what is x plus this was this function, right? So this function I can write it like, think of this way, that I write g of xt, I can write it as summation I in u. What I will write it, I am going to write this function as some, let us say, hi of t, right? What is hi of t is this function. Is that okay? Like something which is like this. I am just my definition, gx of t is by definition it is this. Right? It is x plus some coordinate, x plus some coordinate. So this I am going to call them by HIT. Yeah, now because a function is, if each of these I can show is a convex function, then their sum is a convex function. So I want to show that each HI of t is a convex function. Okay. Now let's look at an hi of t. There are three kinds of them. Okay. What are the three kinds of HIT we have? Okay. Now look at whatever this x plus t EP minus EQ is. Now whatever I do, the only coordinate that has a change is xp or xq. Is that fine? By adding this in the x, I'm only, look at these things when we were doing, right? The only change when you do anything is either at pth coordinate or qth coordinate. Rest are like 0, so you sum them, subtract them, it means nothing. Okay. Now look at, so what is the meaning of this? Okay. Look at an element I. If it does not appear in the set SP or it does not appear in set SQ, then what is this function? No, that is not the point, right? If I does not belong to, if I does not belong to SP and SQ, what is this function then? It is a function which is independent of t. It's a constant function because x, every element of x is fixed, so it's a constant function. Is there a t appearing here? Will a t appear here? I don't think anybody understanding anything. Like, look at this, right? I mean, if I look at x plus this, what is this term? x1, x2, dot, dot, dot. Some t times xp, some t times xq, something, right? So if a set, look at this HIT, if an element does not appear in the set SP, it doesn't appear in set SQ, then these two guys are never going to be part of this product. So if they are never going to be part of this product, then this particular function is independent of t. It's a constant function. Okay? Constant functions are always convex. Okay. Okay? Okay. So now let's define a constant. What is my Cx? I want to define a constant Cx, which is nothing but okay, product over, so I'm trying to understand this function. So basically I can write this function. What is Cx? Okay, how did we define? J in 1 to m. If you look at J into m, I in Sj, okay, and I want to call it differently. I not equal to P, I not equal to Q, okay, and I'm going to write it Cx is 1 minus xj. Notice this is a fixed constant for each term. In these terms, there is no t. Okay, I'm not saying that I is not contained inside. So now I have three things. First thing, I does not belong to SP, I does not belong to SQ. Then this function is nothing but Cx itself. Is that fine? Now I could have that I belongs to SP, I does not belong to SQ. Right? Or I could have I belongs to SP, I also belongs to SQ. Then I will have something. You understand my point? No, yes. Okay. Okay. So now let's try to understand these functions. Okay. So this is what I want to understand. Okay. So if this is what I write Cx is, then what is my hi of t? Hi of t as a function, if I'm in the first case, it is independent of t. There is no t here. Now let's look at that I belongs to SP and I doesn't. I mean, there is also I have to say I does not belong to SP, I belongs to SQ. And there's also a case here. But like, okay. Now let's look at this particular case. What is this function? What is that function? What is this? Can someone tell me? In that case, what is this? I have written Cx. What will that be function be? Then in this case, can I write my hi of t is what? 1 minus product of something, right? Okay. So what is this? So this is like 1 minus Cx, that's the first thing, right? And there's one more term, right? What is one more term? Corresponding SP. But what is a term at corresponding SP? It is this. So what is that? It is T times what? EP. So what is this? This is basically what? What is that? It is not a question of convexity. There is only one term. 1 minus what is the on the place of xp? What should I write? It is just xp plus t. This is all that it is. Because what is EP? T times EP minus EQ. So if you think of this x as a vector and t, so at the pth coordinate t, other coordinate it is minus t. So this is xp and this is xq. So xp plus t, xq minus t. That's all that it is. So this is all that it is. This is all that it is. Okay? In this case, other. What is Cx? For each I, it's a product of. I shouldn't write this. This is what Cx is. Just product. This is my bad. Okay? This product. Right? All those terms that does not have t, they are constants for me. So I just multiplied these numbers. That's all that Cx is. Okay? So now what will be in the third case? I does not belong to SP, okay, and I belongs to SQ. So what is this? It is 1 minus xq minus t. Okay. In the third case, what will be? 1 minus Cx, multiplication of these two terms, right? 1 minus xp minus t. What is this? And 1 minus xq plus t. This is what this function is. Is that fine? Right? So, so my HIT is either this, or it is this. Okay. Either way, okay. So what can I write? This is nothing but some, if I do something, it is like some t square, I can write it t square Cx plus t time some linear function. This is what it is, right? Linear function of t. If you do this, you can write it as a linear function of this, t square times some Cx plus linear function of t, right? And this, now, hey, as I told you, a function is convex if and only if everything is this, right? So if you show that a function is what you call convex in t square, a function is convex in t, it's for you to go and show that this is a linear function of t is always convex. This, I can just try to show you why t square is convex if you really want it. I mean, not that I have very much interest in proving that t square is like some convex function of this, but this is like a classroom exercise. I mean,
T square Cx is a convex function.
Yeah, Sushmita, but like it doesn't matter. If you know how to show t square is a convex function, multiplying with some constant will not change anything in the world, right? What is a convex function? What is a convex function? What is a convex function? A convex function is like this, so that if you look at any two things, if you multiply with t everywhere, it will like this.
The t square being a convex function basically means the function fx equal to x squared. That parabola is a convex function.
Yeah, whatever. I'm saying this is how the convex function. This is convex. What is this? No, this is concave. You are right. Convex is something like this. Yeah. So if I look at any two things, this is an upper bound on this term. Fine. Correct. Okay. You are right. Okay. So now, if you look at this and you multiply with some constant, what will happen? Every point will jump by something. So why it will change? I mean, if you really want to show that f of t being t square is a convex function, then what you have to show?
Y equal to x square is that parabola.
If everybody agrees, then I am not going to prove this. So this is basically all I have showed to you that this is a convex function. Okay, First of all, I broke it down as a finite sum of convex function, finite sum of function, where each function is a convex. So finite sum of convex function is also convex. You can just show theta 1, theta 2, sum them up, and like, yeah, this is okay. I am no mood to do this homework exercise. Okay. So only thing you have to always use, like it becomes a bit tricky, is that you should always use that if x1 is not equal to x2, then x1 minus x2 square is greater than or equal to 2x1 x2. You will have to use this, otherwise you can keep trying and it may be a bit difficult to show. If you want to show this is okay. Anyway, okay. Okay, so we have shown that our max coverage function has all these beautiful properties. Okay, I have still not showed you that point-wise correlation between fx and lx. Okay, okay. So let's suppose we had some other question like, so this method is very useful for many modern things. For example, if you wanted to have a submodular maximization with matroid constraints, this is the way. But I cannot do this because there are a lot of polytopes and all those things involved, which is slightly far away. But let's say I did give a following exercise in the homework. Okay, what was called colorful coverage. Okay, I defined a function called colorful coverage, where universe was universe. My family was divided into F1 disjoint union F2 disjoint union Fk, and our objective was to find F1 in F1, Fk, S1 in F1, Sk in Fk, that maximizes the union. Right? If you notice that when Fi is like, yeah, so from each, right? So, is that fine? So this is what our function was. This is what colorful coverage was, right? For you, for which you provided a factor half approximation, right? But can I write something like this? Then what will be my polytope? What will be this and what will be this for this colorful coverage? Does the same thing will work? I'm just asking a question.
We have to check for colorful.
No, but how? Wait, that's okay, but that's my optimization function.
You mean you just want to change the P and retain
I like.
coverage?
I mean, this is a coverage, right? This is a great coverage function.
Yeah, so then we have to encode the colorful property in the P.
Yeah, so put it. What's the big deal? So P colorful coverage is nothing but x, right? X in 0, 1 to the power m, right? And now for all I in 1 to k, right? Summation j in Fi xj equal to 1. That's it. Right? It tells me that from each color class I pick up one element, right? For each I in 1 to k, look at, so for each I, j in Fi, j in the xj equal to, right? So it's a polytope. Will Pa hold? Will Pa hold? I gave you a feasible solution, which is non-integral. If will it hold? Wait, Sushmita. Yes, no? Look at the sets of the same color, that is exactly equal to 1. So if the first set itself is non-fractional, then you find two elements there, you flip them, right? When you flip them, you just sum them up, you will see that the sum is still 1 in all the summation.
Sorry,
Imagine yourself. Now think of your vector as this x vector.
But why do you argue with flipping thing? I don't understand.
This is how I flipped. This is how I did, no? Here it is. Look at all these xi. Wait. Look at all these xi's. This is for color class. This is for F1, F2, and Fk. Right? So if I have a non-fractional value, then I have a non-fractional value, suppose at the pth coordinate here. Then I know that the first of the sum is 1, which is integer. So I will find a non-fractional coordinate here also, which is in the same color class. I keep everybody else.
Basically, from the first those F1 positions, you'll find one coordinate in which
Wait, listen to me. If this is not integral, it means there is a non-integral coordinate. Okay, let's find the first time I find a non-integral coordinate. Suppose this is the pth coordinate, and suppose it belongs to the first color class. It means in that same color class, I will also have one more non-integral value.
yeah, because otherwise they can't add up to 1.
That they cannot add up to 1. So I will change. So I will first fix. I will fix from left to right. Right? So I'll first fix first color class. Then I will fix second color class, third color class. And the way I'm fixing, if you notice, I never change anything else but the coordinates that I'm varying. Right? That's one thing. But I also now need to show that there, which I did not do before. You should not have asked me question, because if it is a feasible, the summation of xi should have been equal to k. Right? So, but if you notice the way we are dealing with, if you sum those numbers, it is going to be the same thing.
Yeah, if all the fractional values add up to k, then all you are doing is
Whatever I'm doing, I have to show it.
you just sort of compress all the fractional values from one class into just one coordinate.
No, Shishma, no. That's a different thing. Or like I have to show.
The addition will remain the same. So instead of 5,
We have to show that. No, we have, even here, I did not show that the fractional values remains exactly equal to k. Otherwise, I cannot apply that this is still feasible, and hence let's go ahead and doing it. I did not show to you. But what did I do? Like you fix anything, let's say, let's fix something, okay? So let's fix some xq was there, and suppose this is x1, x2, xp, xq, and this, okay? And say this is xm, right? Now suppose my minimum was xq, then what was, and I was doing this alpha x plus vx, then what will I add, right? Then here it will become what? xp plus xq, and rest of the values remain same, right? And what will xq becomes to? 0, right? So if you sum them up, this is exactly equal to the sum of the other things. And this happens in all the 4 cases, so this is exactly equal to this, right? And similarly, when you do here, whatever you will do changes here, this change will be exactly equal to this change, and the rest anyway remains same. So this property will never be violated. Okay. So because of this, you can show that for this colorful coverage also, you have to show several things, but at least it satisfies property A, and property B. You can again show it's convex the way I showed just now. It's not a big deal. It's like it's the same thing here, right? So like if you pick up 2 elements, either you're going to get a sum of a linear function, sum of a quadratic function, or sum of a constant function, right? So we could have applied a Pepys rounding on this colorful coverage also, except that how they are related to Lx and Fx we don't know. If we had a good relation there, then that would imply something interesting, which I have not done yet. Okay, so we'll get there when we get there. Okay, so during this process you can show 1 minus e approximation. In fact, even here you can show 1 minus 1 minus 1 by f to the power f kind of approximation. Okay, but let's go back. So you understand what Pepys rounding is, in what kind of setting Pepys rounding can work, and there are many more settings where Pepys rounding works. It's just that, like I only know a couple of them.
Do we always work with that function fx, so that that function fx is in our control? If we define it like for a different problem, there can be a different fx, right?
Yes, but that should satisfy those two properties.
Yeah, that's all.
Okay, so I'm going to rub almost everything on this board. I don't need it anymore. My God, this at such a slow pace. Now that you have seen convexity, we will see concavity. Okay. So, this was the non-linear programming NLP 1, NLP 2, non-linear program 2, but we also wrote a non-linear program 1, which was basically an LP value. Okay. Okay. So, that was we were optimizing, which is less than equal to LP of what is it called, LP of max of Lx and x in the polytope, where polytope always will mean that. Okay. And what was L of x, if you recall correctly, what it was? It was for summation I in U, minimum of 1 comma and the summation, right? What was this? J in 1 to M, I belongs to Sj, Xj, right? This is what I wrote. And since it came from LP, we know how to solve it, like how to solve this optimization function optimally in terms of LP. Okay? And we said, hey, and since, so what was the algorithm doing? Algorithm was solving this, getting some x, interpreting this x as this, and then running Pepys rounding. Pepys rounding giving us integral solution, which we output, and then we showed that if point wise we have a very good relation between x. So basically what he says that look at this value x, right? Look at this value x and look at what is the value of f on that particular point. It is not too bad compared to L of x, right? Because think of this, but why it is. Look at, we know that opt is less than equal to L of x. We know this. If imagine at the same value x, if the same value x, f of x was equal to L of x, then what will happen? If at that point f of x was also equal to L of x, then what will happen? I said, ha ha, I found a great point x, now make it integral, right? Then so that f of x integral is greater than equal to f of x, which is greater than equal to L of x, which is greater than equal to opt. So I have got an integral value which is, so this is equality, right? So the only reason I cannot get this is at this point the value where fx is, the value of f of x is smaller than the value of L of x, right? But we will say, oh, it is not too small compared to L of x, it is at least some fraction of L of x, right? Some fraction of L of x at each point, and hence that fraction is my approximation factor. Is that fine? Okay, good. So that's all that is happening here. And if you recall correctly, we fix the constant here. So what did I define? If I recall correctly, I defined I defined a function rho of x to the power x, okay? And I said that for all d less than equal to f, right, rho d is greater than equal to rho f. This I showed last night. Now, what is the lemma that I want to prove? That for all x in P, for all x in P, f of x, that f of x is greater than equal to rho f times L of x, okay? And what was f? Maximum number of sets an element can occur. Is that right? So this is what we started with, right? So this is what I want to show. Is that fine? This is my goal. All good? So let's try to prove this. Okay. What does AMGM tells us? Suppose I have n numbers, how will you say this to me?
Sum over xi by n is greater equal to n
Okay. So, if I have numbers say y1 to yn, what do you say? Wait. Summation yi from 1 to n n product of yi to the power
1 by n.
Is that fine? Okay. Okay. So, now what I am going to show to you, fix I in our universe, okay, and what I know, I appears in at most say D sets where D is less than equal to F. Okay. I fix I in my universe and suppose I appears in at most D sets where D is less than equal to F sets. Okay. Now, I want to understand this term. So, what will I write here? Product over j in 1 to m, I belongs to Sj, 1 minus xj. I think of this 1 minus xj's as equal to yi, then what can I say? This is less than equal to what? Right? Is less than equal to 1 minus xj divided by d to the power d or 1 over d. I think this is correct. Huh? Is it fine? Because the product is over d sets. So, this is fine. Okay. So, can I write this as 1 minus summation xj divided by d to the power d? Because it is a d terms, right? So, d. Is that okay? Let gt equal to 1 minus 1 by d to the power d. T by d to the power d. Okay? I am trying to prove this lemma. So, let us take gt equal to 1 minus 1 by t by d. Okay? You will tell why I am fixing this. Okay? Then for d greater than equal to 1 and you are in the interval what? 0 comma 1. Okay? What is the function gt? I claim to you that gt is, what is this function gt?
T is the max of those d's, like the frequency.
No, gt is a function. It's a
What was t?
t is nothing here. Where is t?
You said d was at most t, right?
D is at most f.
Sorry, what is t?
T is a function.
Yeah, t is a variable.
T is a variable, right? I want to say that then for any d greater than or equal to d 0 1 gt is a concave function.
What is that range 0 1? Like
T takes a value between 0 and 1. Okay? T takes value between, okay? For d, you are right. Let me put it as t into 0 comma 1. This is a concave function. Okay? No, there are like several ways to show that something is concave function. The concave function you can also show. What is the definition of concave? But what is the definition of concave function? You don't remember? You know convex function?
Like
Wait. So, concave function is this. Function value will always be greater than equal to point joining this thing. That's all that it is. Right? So, this is at least this is how I remember. I don't know what it is. Okay. Basically, what we have to, this is basically f of theta a plus 1 minus theta times b is greater than or equal to theta times f of a plus 1 minus theta times f of b. Okay. This is the definition, right. Of course, in the interval, like whatever, like suppose over what? Over some C where C is a convex function, is a convex set. Okay. And here my C is a convex set, right, because you take any 2 points, take the line between them, it is inside there. So, this is convex set. Okay. Domain is a convex set over C, and here my domain is a convex set because look at 0 and 1, look at any 2 points, draw a line between them, that is in the set itself. Okay. So, GT is a concave function, I am not going to show to you, I mean this is like, yeah. Okay. I mean like it is like 4 page of differentiation integration, I like, okay. But it is, okay. Because now what we can say, think of this as a, there are 2 things, right. So, suppose I write 1 into t let us see. So, I want to compute here, okay, on the extreme.
Saket?
Yes. 1 second.
Hello?
1 second.
Yes.
Wait, Sushmita, 1 minute. This is fine. Is that correct? Tell me.
Are we assuming the summation xj is between 0 and 1?
Summation xj is between
0 and 1? It can be more than 1 also, right?
summation summation xj. Wait, why are you saying summation xj could be? Let's see. Maybe you're right.
At the constant, at least in the original LP, it said summation xj is at least this y or z variable.
So, this is what it is, no? It is a minimum of 1 comma this that we are trying to optimize, right?
Yes.
So, summation of xj. You are right. So, think of this way that, yeah, that is right, even if I substitute xi is at most, but look, but you are right, I mean this could be summation of xj could be negative. And what will that change? Even if it is negative, will it change something?
Why will it be negative?
Wait, no, what he is saying that look at summation of xj. But look, what is each xj is at most 1, right?
Yes.
Okay. And how many sums are there? At most d.
Yeah.
So,
That is true. Yeah.
yeah, that's it. So, it does not matter. Right? So, it is at most 1. Okay, fine. But is this fine? If it is a concave function, then I can write like this. Okay. 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 And what is g of 0? This is like, what is it called? Mean value theorem or whatever. Okay. What is g of 0 here? Wait, what is g of 0 here? Is it 1? Why? Oh, this is 1, 1, this is 0, right? And this is t times, what is g of 1? G of 1 is f, rho of d. Is that fine? So, g of t is at least rho d time, okay. Is that fine? So, g of t is at least t times rho of t. Is that fine? Okay. Now, I would like to substitute this in one of these inequalities. Oh my God. Oh, this is not fun. Okay. Okay. So, this is like, these are some of the things people should do themselves. This is not something. Okay. But let us see. Okay. We have it.
So that is where we like you assume that t was between 0 and 1, right? And for us t is summation x here.
That's right. No?
Yeah, so summation xj by d might be less than 1, but summation xj itself could be more than 1, right?
No, well, let's.
That's the point. No? It can be at most d.
Oh, okay, so let's see now what I want to do next. Like like, what are you trying to say? Okay, maybe I made some mistake, but let's see. Is this fine? Okay. Now, what I wanted to do is that I wanted to. You are right. This is what I wanted to understand. 1 minus product j I in S j 1 minus x j, right. This quantity is at least 1 minus okay, what should I show here? I just now showed what did I, you are right. Okay, so t is equal to yeah. So, this is fine. Now, t is equal to summation x j by d. This is what my t is. Can't I use that?
Why not just do summation of xj? T is equal to summation of xj.
So, no, what I am saying that look, this quantity is less than this. So, if I do 1 minus this, 1 minus
Within
So then
0
you
and
want
1.
to compare the expression you get after 1 to gt, right? So that way summation of xj should be t then.
no, this I can write this quantity is at least greater than equal to 1 minus. Is that fine?
But t will belong within 0 and 1, that range.
Is this fine?
There.
And to the power d. Is this okay? Is this fine? At least as a term.
Yes.
Yes.
Okay. Now, what is this term? G of t is 1 minus 1 by t by d to the power d. And you say that I took t between 0 and 1. How do I know that t is summation x g is in? Is that what your question is?
Yes, yes.
Okay, that's a good point. That's a good point. Why do I know? That's a very good question. T is between 0 and 1. That's a good question. So, if I wanted to use this to show something,
Is the definition of GT okay?
I think so, otherwise I can't prove. Wait, this is like something what I want to show. I am being idiot. I am being idiot. I am being idiot. Okay. But if I want to show that this quantity, okay, you are right. You are right. Look at this quantity. Okay, fine. Look at this quantity. Okay, you are right. There are two cases. Summation of xj. What you said. This is what I suppose if I wanted to use t for this, right? Is that fine?
Yeah.
Okay, then what happens if this is equal to t? If I wanted to use, and suppose we were able to do this, then what can I conclude from here? Then I could have concluded from here that this is nothing but,
So right hand side is equal to GT.
no, this is summation xj times rho of d. Is that fine? If I could apply this, is that correct?
Yes.
If I could apply this, then I can show this. Okay. Suppose I am not able to apply it. Why am I not able to apply it?
Because it is more than one.
If it is more than 1, if it is more than 1, right? If it is more than 1, let us try to understand, right? So, if t is less than equal to, t is this, t is less than equal to 1, I can conclude this. If t is greater than equal,
What is the term given?
then this is this, right? Because then I can apply this lemma,
Yeah, okay.
right? Okay. But if t is more than 1, what can I say about this? If t,
Yeah, then we already get it 1 minus 1 by d to the power d.
no, so what we get? If t is more than 1, if t is more than 1, then what I get? 1 minus,
Summation xi is less than 1, so we get it 1 minus.
no, if summation xi is less than,
No, more than one.
more than 1.
Yes.
So, if it is more than 1, look at this. If it is more than 1,
It still can't be more than D.
So in that case, we want to show that this is more than min of these two things, right? And that
Yeah, yeah.
min is 1 now.
yeah, this is 1, right? It is at most 1 in this case. Okay, let me show to you. Okay, so now suppose t is more than 1, like summation xj is more than 1, more than 1. Okay, so if summation xj is more than 1, okay, so then this becomes 1 minus d minus summation xj times d to the power d. Okay, this quantity summation xj is more than 1.
But it's a positive quantity, D minus.
Doesn't matter. That is strictly more. So this quantity is strictly less than 1. So that power is strictly less than 1, right? So this quantity is strict, like this is right. So what I can say that this quantity is greater than equal to minimum of whatever is minimum. This is right, because 1 times summation xj times no, here also we will get rho d, no. So what I am saying is that, look,
But you can't apply
wait,
the definition of GT anymore because GT is only defined for T being in the
wait, that's okay, I am not applying it here. Suppose summation xj is, what can I say here? What I have to show that this quantity is something, right? What is my rho d is 1 minus x to the power. Okay, so all I want to show that in this case this is okay. So what I want to show, if t is greater than equal to 1, then this quantity is already greater than equal to rho d. This is what I want to show. Which is fine, right? Why it is fine? Because look, 1 minus 1 by, suppose I have some a by d, okay, I want to show that this is greater than equal to 1 minus 1 minus 1 by d to the d, okay. Yeah, fine. So 1 you get cancel, and so 1 minus a by d to the power d is less than equal to 1 minus 1 by d to the power d, right? So d gets gone away, right? So all I care about at this point of time, that 1 minus ad, so 1 will get cancelled, right? 1 and 1 get cancelled, d 1, so a should be greater than equal to 1. That's it. Is that fine?
Yes.
That's it. Okay, so you are right. Okay, so if t is greater than equal to 1, okay, so we have two cases. T is summation xj, okay, t is summation xj, and t is greater than equal to 1. If t is greater than equal to 1, then if t is greater than equal to 1, then this is greater than equal to rho d. Otherwise, this is greater than equal to summation xj times rho d, because t is this. Is that fine? My God. Okay, so I can show that either, so in this case this quantity is greater than equal to minimum of 1 comma summation xj comma rho d, whatever is the minimum of quantity. Is that fine? Is that okay? So what is the meaning of this? So this quantity is at least one of them times this, minimum of this, at least. So either this is minimum, whichever is the minimum of these two quantity, right? So this is at least rho d. Is that correct? No.
No, minimum would be much less than it can push down the value of it.
It can push down the value.
But this is sufficient, right? For every element we showed this.
for every element, what did we show? I wanted to show that this is greater than equal to rho f by monotonicity. Is that correct? But like this is why this stupid maths. Minimum of 1 comma summation xj times rho d, and why did we get summation xj? For the case when, yeah, so this was less than 1. So this quantity is fraction of rho d. So why will this imply this? This doesn't imply, right?
No, but we don't need it, right?
I don't-
We wanted to show, we just need the previous line.
Yeah, I don't think we need this. Okay. Now what I want to do is the following, right? So this is what we showed for a particular element. What we showed, this is at least rho times t. Now what will I do? But I wanted to show for everything, right? So I will sum over everything this quantity. Is that fine? Element, right? So now I want to prove this, right? That fx is rho f times Lx. Okay? Rho f times Lx. Okay?
So there'll be a summation, outside summation running over all the elements.
Huh? Okay. So now I have to show this. So what is f of x now? F of x is sum over each of this quantity. Now each of this quantity is at least this much, right? And so I think this we can say that min of 1 comma sigma xj times rho f. This we can definitely say, because rho d is at least rho f. Yeah. So now what is f of x? F of x is this term. This term is at least, what is this? If you rearrange this, this is what you are going to get, right? This is summation over I in u minimum over 1 comma, okay, summation of xj something comma rho f, right? So rho f can be taken out common and you get your lemma. My God. Okay, is that fine? This is a computation which is well beyond me. It's not ideas here. It's like you have to, like, I don't know why this is correct for that matter, but this is correct. Yeah, but imagine what would have been for us if we would have been doing colorful coverage, right? Everything was fine for colorful coverage. Our constraint, the polytope will change, right? This k becomes like some m1 into 1 equal to 1, but there are such constraints, but f of x remains the same, right? Okay, I think the proof will not change anything at all. Will proof change? Will proof change after this, right? So opt is this, it's just the polytope definition changed, right? Nothing else will change in this, right? I can still apply my AMGM inequality for each correct, right? Because all I care about, like, it's not about the points, right? Because it is all about this particular function that we are trying to maximize at that point of time, right? What kind of point you have got, that is already fixed by this quantity, like this the polytope property, right? Once you go here, I can again say, hey, look at my f of x, right? Look at my f of x, let's fix an element, look at its quantity, like which all sets he is there, irrespective of the colors, it doesn't matter to him, because when I wrote that optimization function, I did not care, right, which color classes you have, whichever sets you appear, I wrote it, right? Whether you are going to pick one set from the color is given by these constraints, okay? So if this does not matter, then I can fix this. This will be again a convex function. Again, I can do either this or either this. So whole the proof will go through. Is that fine, Tanmay? Do you buy this?
Yeah.
Okay. So if I just change the polytope,
So as long subset of the bigger polynomial, because when you're adding the coloring constraint, you're just adding a constraint to the original polynomial.
I don't know, but look, but like I do not know any of these things. Like how does it?
That just reduces the
Yeah,
points.
but no, it is not original. No, the problems are very different.
No, the original problem, I mean that summation of xj is being equal to k.
Yeah, but those are completely different problem because there was just one constraint. There I do not have. Look, when you say constraint, you have that constraint and you add more constraint. But I am not doing that. I cannot say that this and these two things are very same.
You still need the k size properties. Yeah.
No, I don't need. That is already given because from each color class I pick one.
Okay. Yeah, but so that's
I mean,
self-enforced.
no, but like I actually don't think that a solution there, a feasible solution here and feasible solution here has any property. Like because these problems have entirely different structure.
Okay, but from here can we still say what our approximation using pipette rounding? It should give us a
Yes, this is the approximation again, rho f.
better than half.
It is rho f.
Yeah, it's perfect.
It's exactly the rho f.
3D gives half, right? So it should be better than that.
It doesn't matter. Like this is exactly what it is. This is what I showed. Okay, too much. Okay, so we'll meet tomorrow at what time?